Thank you for coming to my talk. I'm Youngmin Choi from Line Plus. I'll be presenting our new model for multiple conversions based on delay feedback model. We'll start our presentation with an introduction. In introductions, we'll talk about the problem we have to solve, especially in conversion prediction. There are already some well-known studies about this, and we'll explain how our proposed model approaches and solves it differently. Finally, we will discuss experimental results using our actual data and summary our presentation. Our main goal is to predict the number of conversions. Input data include the picture X and the target value Y. The X value contains user, site, and ad information. Y is the number of conversions. In this problem, the main challenge is the delay, the time interval between click and conversions. The other challenge is that there can be multiple times of conversion. So far, many studies solve conversion prediction as a binary problem by accepting only the first conversion after the click. This table shows the ratio of clicks having multiple conversions of each conversion type in our service. For type A and D, more than 25% of clicks have multiple conversions. We attempt to predict the number of conversions considering all delays together, and the model is ready to be deployed. Delay feedback model introduces the first way of optimizing models for conversion and delay together. This model predicts the probability of conversion using lowest regression and fit the distribution of delay using an exponential distribution. However, in our model, we're using negative binomial regression for countable conversions and order statistics for multiple delays. Before we explain our model in detail, we'll introduce some variables and notations. E is elapsed time since the click. In other words, the time interval between click and training time. If E of sample is too short or the delay of sample is too long, additional conversions could occur sufficiently after the training. If a model ignores the delay, it could underpredict the output because it is optimized to predict only the number of conversions collected before training. So there are two variables for conversion. First, Y is the number of conversions at the training time. And second is C, the number of conversions which could be observed eventually. They can have a value from 0 to infinity. In this sample, Y becomes 2 and C becomes 4. And there is one variable D for the delay for each conversion. Our model is MBDFM, delay feedback model with negative binomial regression. Our objective function is negative normal likelihood given observed samples. And we estimate parameters by minimizing this objective function. We use LBGFS optimizer and the details including the gradient are explained in the paper. With the parameters in the previous step, we can predict the exact number of conversions. In the next part, we'll focus on how we get low likelihood given samples in our model. We need two models when construct low likelihood. One is for conversions and the other is for delay because they are used in calculating low likelihood. It will be explained in the next part. First, to predict the probability of k conversions occurring, we use negative binomial regression. The second is the model related to delays. If k conversion occurs, we can get k delay, d sub 1 through d sub k. We use order statistics to fit the joint distribution of them. This page shows the brief idea of how to get the log likelihood for a sample. Suppose y is equal to a, then you can also get x, e, and a delays, d sub 1 through d sub a. In this case, the number of eventual conversions, C, can be A, a plus 1 or a plus 2 even up to infinity. And the probability of each case is equal to the probability of given number of conversions by the law of total probability. We can get easily check that if C is a plus 1 or a plus 2, delay this of a plus 1 or this of a plus will be greater than E. So the event expressed Y and D can be re-expressed as C and D. And those of probability models are explained in the previous page. Therefore, by considering all these cases that could happen, we'll obtain a likelihood for a sample Y is A. Let's go in depth by taking a look at the numerical expression. If Y is A, then C can be A or more than A. So line 1 is equal to line 2 by the law of total probability. In line 2A, which is a part of line 2, Y is A given by conversion C is K means all delays observed after training time, this sub A plus 1 through this sub K will be greater than E. So line 2-A is equal to line 2-B. Line 2-B is re-expressed by the only variable D. So using the PDF of delays, we can calculate the value of them like line 2-C. In line 3, you can notice we have to deal with infinity sum, but it is simplified by negative binomial theorem. This is one of the key parts of our model because it makes model be deployed easily and with low latency.
Hi, my name is Kwon and a colleague of Choi. From now on, I will introduce our experiment in detail. To the best of our knowledge, no data set has been released publicly to evaluate the models for multiple conversion prediction. Therefore, we used our line's internal real traffic logs for evaluation. The first 3 weeks are used as a training set, and the following day is used as a test set. Conversions can be occurred even after the training period, but we only use conversions which can be observed at training time. Unlike the training set, to evaluate precisely, the test set must include all conversions. Note that we repeat 7 times over 1 continuous week to check the consistency of the result. We used MSE, which is mean squared error, and calibration as evaluation metrics. We compared our MBDFM to DFM, GRMs, and DFM plus Poisson. Especially DFM plus Poisson is our first deployed heuristic for multiple conversion and is briefly explained in the paper. As described previously, only conversions that occur during the training period are used in the training set. However, in case of Oracle GLMs, we include all conversions that occurred even after the training period, just like the test set. Therefore, those are considered as an upper bound in our experiment. Next, I will report the MSE and calibration of each model. Here, table shows that our MBDFM is the best in terms of both MSE and calibration, except for the Oracle models. And models considering only one of delay or count tend to have a high calibration, which denotes the conversions are under-predicted. We also show daily result in the paper. On recap, our proposed MBDFM solves real-world conversion prediction problem. That is the key of CPA-basis RTV auction, which occupies the largest portion in online advertising markets recently. Mainly, we introduced a method that jointly optimizes both multiple conversions and delays. Therefore, we achieved a significant improvement in our experiment. Despite the powerful performance, our MBDFM is pretty simple to deploy on production service. Also, I'm looking forward to discuss more in the Q&A session. Thanks for listening.